It's not just fun, it's the law.
Greetings, the Asteroid 30 here yet again with another semi-interesting video. Today I'm going to be looking at, well, the concept that was come up with by Darren Yates back in 1994 for Silicon Chip magazine, called the Champ Amplifier. Now, basically, Champ means cheap amplifier. That's what he meant it to mean. And the actual power amplifier that goes with this board, this is the preamplifier by the way, uses an LM386 Craptoid IC. The LM386 is the worst amplifier to drive a speaker ever. Well, at least the LM386N. They're only capable of about 360 milliwatts, and they're very hard to tame. They howl, oscillate randomly by themselves. They're very hard to use, but we won't go into the power amplifier side of what this was designed for, but we'll actually go into what Darren Yates wanted to do with this project, but never did. But anyway, we're going to look at the preamp first. It comes as a kit from Jaycar. It's KC5166. Requires between 6 and 12 volt DC to power it. And the construction time is basically no more than 15 minutes. So we'll open the box and we'll have a look at what we've got here. Well, we've got, well, that's the first time I've seen that, the circuit board's actually in the plastic bag with the parts. Nice. But we've got the circuit board there. It's a fairly simple layout. It's not that overly complex. Single-sided. No link wires by the looks of things. No, it's just basically, yeah, just put the components on and everything's all routed where it should be. Anyway, uses BC556 and BC546, I believe. Yeah. So we'll have a look at the instructions. Now, there's something you don't see in a Jaycar kit very often, is the actual artwork for the PCB copper side. But anyway, this will come in handy a little bit later, and we'll see why. It's a 2 transistor design. That's an input transistor, that's the output transistor. And we'll notice there's this 10 microfarad 16 volt cap here. This is basically operating in class A. So this is the input transistor, and this 100 ohm resistor together with this 2K2 is basically forming the gain of the amplifier. This is what controls the gain. So it works the same as an op amp basically, whereas you divide that resistance by that resistance plus 1 gives you the total gain of that circuit. And that's fed into the emitter of this transistor. It's basically the same as if this was a long tail pair where you have 2 transistors and you're feeding these 2 resistances into the inverting input of the amplifier. It's a similar thing, but it uses less parts, and well, it's not as good doing it this way, but it works. So with those 2 resistances, yeah, we're looking at a gain of roughly 23. So, thereabouts. So, yeah, there's not much really more to talk about this circuit, except that it's not hi-fi. This is mainly designed for driving a, well, with the correct amplifier at the output, but for driving speaker drivers such as this in portable radios, etc. So nothing more than like a 1 to 2 watt device. This is a 2 watt 8 ohm device, but yeah, something similar to this. I thought that was badly manufactured, but no, it's alright. But we'll look at a better power amplifier solution to drive this speaker than the LM386 that goes with this preamp. And it'll all make sense a little later. But so this video is going to be probably a little bit long than normal. I hope not. But I'm going to build up the circuit here. I'm going to test it on an oscilloscope and function generator. Sorry, I've got reflux. And I'm not going to take any video of assembling this kit. There's no point. So I'll assemble it and we'll come back when I've assembled it. Couldn't do that twice if I tried. As you can see, I'm building this without using my little helping hand tool at all. I don't see the point or necessity for a small board like this to use it. I might, however, mount it into one of the alligator clips of that magnifying glass helping hand tool, just to just hold it up there so I'm not constantly fighting with it on the desk. And that's sort of what I meant. That's basically all that's good for now, really. And I'm making up those sodding 2, 3, 4-way connectors that I loathe so much. But yeah, this is a fairly simple build. There's hardly anything here gotcha wise. You just gotta make sure you put the right resistor in the right hole. Penis. No, I gotta stop doing that too. The module is complete. I misspoke when I said BC546 and BC556. I meant 548 and 558 respectively. I made a mistake. Anyhow, that was relatively painless and simple to build. Overall quality of the board is questionable. So now what we need to do is hook it up to a 12 volt power supply. So I'm going to run it at its maximum of 12 volt. However, yeah, these are 16 volt caps. So remember, it's always a good idea to stay close to, if you can, 5 volt under their maximum rating. At 12 volt we're going to be 3 volt under their maximum rating, but we can't go any higher than that, so we'll stick at 12 volt. If it ended up being 12.6, so be it. Now, I don't expect this to have a very good frequency response, mainly because we're going through a 100 nanofarad input capacitor here, so we're not going to get the full range anyway. But as I said, it's being into a power amplifier that's designed to drive a mid-range sort of small tiny tinny speaker like you find in radios and shit. So anyhow, I'm going to stop talking about this and I'm going to set up here to do some tests, and we'll actually have a look at how this little discrete preamplifier performs. Okay, I've got everything set up. I've got my DDS currently set to the default setting of 1 kilohertz 1 volts, the one thing I always seem to use. However, I don't think this little circuit is going to like 1 volt peak to peak in, but we'll soon find out. Oscilloscope's hooked up to its output, so basically we're going to see what happens when I apply 12 volt DC, this is single ended by the way, to the circuit and see if we get an output on the oscilloscope. So we do, but we can also see the artifacts of the output capacitor charging there too. But we are clipping badly, so we need to change the amplitude, so I'm going to halve that to 500 millivolt, and we're still pushing way too much, so 250 millivolt, that's a little bit better. but it's kind of noisy. So we're pushing a peak-to-peak output of 4.7 volt. So that's at 200 odd millivolt in. Now I'm not sure if that's maximum input. We're now at 300 and I can't see it clip yet, but who knows. Come on, 2 volt per division. So we're at 300 millivolt in, pushing 6.7 out, and we're flat bottoming at 400 millivolts. So I'm going to ballpark it at 350 millivolt. That was the wrong way. This rotary encoder on the DDS doesn't work too well. As expected, I know that if I hook something up like a CD player to this, it's going to distort the hell out of it badly. But it does work, well, at 1 kilohertz. But what I'm interested in now is what is its frequency response? So with a 20 hertz to 20 kilohertz sweep, let's find out how good it is. Well, there we go. Well, up to 8 kilohertz, 10 kilohertz, remaining stable at 6.6 volt, 6.5. It's not actually that bad, really. Starts at 6.7 at the low end of frequency response, and drops off to 6.5, so it's not perfectly flat, but I'm actually quite impressed. Wasn't expecting that. So, well, it's got a reasonably hi-fi frequency response to it. Okay, so now we need to move on to something a little bit different. Okay, this is Darren Yates' reworked version, and the one that he actually wanted to use in the end for the Champ amp, but ended up using an LM386 instead. And he said, and I quote after reading his website, I'll put a link in the description below, that if he had his time over again, this is the amplifier he would have used. Now, he reckons it's a 1 watt RMS, so using the old RMS scale, but at least capable of 1 watt RMS. So I'm going to go out on a limb here and say 360 milliwatt peak, around about there. We'll soon find out. You'll notice up here, this front end of the amplifier is exactly the same as the preamplifier. That's because it basically is. All he's done now is he's added a 337 and 327 output stage emitter follower here, which is operating in class AB with a self-biasing network here. And the feedback path now comes off the output of the emitter follower rather than the output of this transistor over here. So, it's a fairly simple circuit. It's not much difference to the preamp except for the addition of these transistors here, this diode which helps keep these transistors from well, linear, so we're not getting as much crossover distortion as possible. And these 1 ohm resistors, which I'll in the end use 10 ohm because I don't have 1 ohm ones, but these 1 ohm resistors here, as previously explained, is simply there to prevent thermal runaway, because if this diode is in contact with one of these transistors, transistor heats up, diode heats up, biases the transistor harder, etc., and it goes around in a circle until they destroy themselves. So these help limit the current going through the emitter follower push-pull stage there. And we've got a Zobel network over here formed of a 10 ohm and a 100 nanofarad capacitor. He has got a 1 microfarad over here instead of a 100 N, but it really doesn't matter for all intents and purposes of the type of speaker that we're going to be driving. And in actual fact, looking at the original schematic for the Champ preamp, he did actually use a 1 microfarad on the input rather than a 100. They just changed it in the silicon chip article for whatever reason. But basically what we're going to do is I'm going to build this, well, what I'm going to do is I'm going to build this up on a breadboard, and we're going to first test it on its own and see what its input sensitivity is to its maximum output power, and then we're going to connect the preamp up to it via a little volume control here, just a 10k logarithmic pot, and see how well it sounds into a speaker. And then by the end of this video, or before the end of this video, we're going to do Darren Yates some justice here. Alright, so let's go. Okay, got the little circuit built, as messy as that is, but hopefully it's going to work and I've wired it up correctly. Well, after spending about an hour messing around fault finding the circuit and then realising I didn't have the collector of the transistor up here connected to positive, the emitter of the transistor connected to positive. I didn't have the collector connected to the base network over here of these two transistors. I was right the first time. That gain resistor should have been 1k. The feedback resistor should have been 10. And I also found, after messing around, as soon as I hooked up a speaker driver to the output and ground whilst it was connected to the Crow, I had an output. It does not work unloaded, put it that way. Now we have an output. We've got 500 millivolt going in, peak to peak, and we've got 3.9 coming out. So that's before clipping, so we've got 3.9 coming out. We might divide that by 2, gives us 1.95. Times that by itself. What's that? Yeah, I can see it's only going to be about half a watt. How good was that? Half a watt. 475 milliwatts. For what that circuit is doing, it's going to be pretty loud. So what I'm going to do is I'm going to stick this onto sweep function now, and we're going to look at our frequency response, which is relatively flat. We're staying around about the 3.9 volt peak to peak output. Yeah, that's pretty good wide range frequency response. Very, very good. So what's the next thing? Well, I would put this preamp up to it and put it to a speaker, but I think I'm going to go one better. Because I know that the circuit works, what I'm going to do is I'm going to build the champ amp with a preamp the way Darren Yates wanted to do it after the fact. So I'm going to route a small PCB, etch it and whatnot, drill it and build it. And then we'll do the final test on the completed PCB. I have a friend. I don't know where he came from. I don't know whether he's been stepped on. He doesn't look very happy. Oh, such a struggle. I think I might get rid of him outside. So there's my circuit board all routed and exposed and developed. All I do now is etch it. Penis! No, anyway, about an hour later, the board is drilled, cut, cleaned, and has a coat of protective lacquer over it, just waiting for it to dry. And then it's on to the last stage, well, second to last stage, which is assembly, and the last stage is final testing. Okay, I got all my parts laid out over here, all over the place, ready to assemble. I'll put the connectors on last, but first I'm going to assemble all the small components. Now I have to make a substitution for the 1.5 nanofarad capacitor, which was an NKT or polyester, which is going across the feedback resistor of the preamp. I'm going to substitute that for a 152 ceramic, which should do exactly the same thing. In fact, I think a ceramic would be a better choice anyway. So I'm going to get started in assembling this, and I'll do it in time lapse just for fun. I'm looking for the power adapter to the camera so I can plug it in. and I've just found it. Penis. Right, that took about 36 minutes to build, but I made a mistake. I put a 100k resistor in the wrong place. Had to find a replacement 22k resistor because I had a 2k instead, and I ended up changing one 10 ohm resistor because it looked a bit burnt. So now it's ready for its big test, and hopefully after all that effort it works. We can only just find out. So yeah, time to hook it up to a power supply, a DDS and a DSO. I might use the small one for that, say bring the big one back up on the desk, and just see if we get an output. Wish me luck. Okay, here's the setup. I've got the DDS sitting over here at 200 millivolt peak to peak, 1 kilohertz, which is roughly what the input sensitivity of the preamp was. Power supply still at 12 volt. I've got it running through the multimeter in the background there to measure the current draw of the circuit, and I've got the output into a dummy load into the DSO over there. That DC socket on the DSO is becoming a little bit dicey. Anyhow, I'm going to power it up now and see what sort of current draw we've got, if any, and if anything strange happens. We've got bugger all current draw and nothing on the output yet. If I rotate the control, I still have nothing. Well, that's that's concerning. This may have been a wasted day. I've got no output whatsoever. Well, I do now because the dummy load had come disconnected, but that looks terrible. I'm not sure what exactly is going on there, but it ain't nice. Okay, the output amp is producing a nice sine wave, but the preamp itself is not. So I don't know whether or not that ceramic capacitor is the issue. I could always remove it and try again, see if that resolves the issue. Or I've got a dud transistor, which is also possible. I know it's routed correctly because it's basically routed the same way as the kit is, so it should not have a problem. So I'm just going to have a look at the... Well, I wanted to see what the current draw was. We're looking at about 44 mA at the moment. And when we drive it into clipping way beyond, it's 122 mA. So, yeah, that says point, no, that doesn't even help me, but yeah, that's 0.122 of an amp, so 120 mA. But I'm not liking the output waveform, so I am going to take that capacitor out and have a try again. Might also check the transistors, make sure they're actually functioning correctly. Okay, after dickamifying around, I've finally got the output signal to not look like shit. It was just clipping severely, so I've reduced the gain by changing that 100 ohm resistor there to a 1K5. 1K2 would have also done it. This capacitor I changed from a 0.015 to a 0.047, and that seems to make it sound less harsh. And the preamp is at 500 millivolts input, and I'm getting roughly about 1 volt out, so it's a gain of 2, which is reasonable. So now if I unhook that from there and then hook that back up to our output, which is just there, I'll drop it back off, I'm about 4.86 volt peak to peak before clipping. 4.86 divided by 2 times that by itself, 0.43, oops, equals that, divide that by the load. We're getting close to 738 milliwatts out of that. That's pretty significant for what it is. However, those transistors are quite hot. Those are the two output transistors, the BC327 and 337. So you wouldn't want to run it at that power continuously. It's not getting red hot to the point where it's going to melt. But now if I disconnect the oscilloscope and dummy load from the output and connect it to a speaker, that's just handily sitting here on the desk. Doesn't sound too bad. Just doesn't sound very loud, that's all. I'll pick it up. Seems alright. But of course the higher in input voltage I go, the more it's going to clip and sound terrible. Because now it's starting to sound terrible there. But it's not really pushing any more output. So I'm going to put the sensitivity at the input at 500 millivolt and say leave it there. So what's my conclusion? Well, it works, but is it really usable? Well, to a point it is, yes, but it's not really outputting that much gain. It's about as much as you're going to get out of it. Preamp does make it louder. So, alright. Yeah, it does work as an amplifier. Turn that down because it's getting annoying. It does work as an amplifier, but it's not all that wonderful. But it'll certainly do the job to give you some form of amplification for something like, you know, you're working on a radio front end or something and you want to test that it works, or even as a signal tracer to see if you can hear sound coming through a path of audio somewhere in an amplifier, for instance. So it would work. That's about all I'd use it for. I wouldn't use it for anything high-end or important, but it does work. I'm not going to play music through it. Yeah, there's not much point. We know the frequency response is pretty good. I'm not sure with that modification, with that extra capacitor or change of that capacitor there, shouldn't have made that great big of a deal. But yeah, I'm going to end this video here because it's getting late and I want to go do something else. So I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyhow, this is the Astro 30 saying, see ya. Happy Champ Amp. I have no idea why I keep saying shit like that.